Hello everyone, welcome to this video lesson. In this video lesson, we are solving a problem basing on electric charges and fields in terms of electric potential. The problem is like this. There are two positive charges, point charges, each of magnitude q, placed on y-axis at points 0a and 0 minus a. If you try to draw a diagram to understand what does it mean, so there is a y-axis. This is the origin of the y-axis. At plus a, there is a charge q is placed. At minus a also, an identical positive charge q is placed on y-axis. That's what is given in the problem. If a positively charged particle of charge q0 and mass m is slightly displaced from the origin in the direction of negative x-axis. So here at the origin a charge q0 having a mass is placed. It is now slightly displaced along a negative x-axis this way. It is displaced along negative x-axis. This is negative, this is positive. Then what is the speed at infinity? The first thing we would like to analyze is why it will have a speed. To understand that, let us imagine that q0 is somewhere here at a given instant, as it is moving from origin to negative x-axis. At this point, on this positive charge, due to the positive charge on the positive y-axis, similar charges there is a repulsion. Simultaneously, on this positive charge, due to the positive charge on the negative y-axis, there is another repulsion. So these two forces are identical in magnitude but different in direction. But look at the direction. This is force 1, this is force 2. Automatically, their resultant force will be somewhere in between them. This is the direction of F resultant. As there is a resultant force acting towards the left, the charged particle, so we can say as resultant force is towards negative x-axis, q0 will be keep moving in the direction. In our question he is asking at infinity that q0 has what velocity? That q0 has. Hope you understand the question before you go for a solution. So what we can say is at origin, when q0 is there, the system has, the other way, potential energy. What is the potential energy? We know the formula. Potential energy is 1 by 4 pi epsilon naught q1 q2 by r. That's the formula. So between these 2 points there is some potential energy. Between these 2 points also there is some potential energy. And between the first and last also there is a potential energy. So initial energy is only potential energy because all of them are in the state of rest. So what's the potential energy of the system is 1 by 4 pi epsilon naught. Between q1 and q2 there is a distance of 2a. Between, of course, q1 and q2 are all q's itself. So I am calling it like q itself because it is given that this is q and this is q. Both are separated by distance of this a and this a together, 2a. Between q and q0 there is a distance a. Between this q and q0 also there is a distance a. That's the total energy of the system. Not only potential energy, it's the total energy as there is no kinetic energy at this point. Now they are moving. This particle is moving to infinity. Assume at infinity these two particles are still there itself. Still there will be some energy. That energy is how much I want to write. At infinity, total energy is potential energy between Q and Q. They are there only, they are not moving, plus kinetic energy of Q naught, as Q naught is moving to infinity. So what I can write? Total energy at infinity is 1 by 4 pi epsilon naught QQ by 2A is there, and this is moving. How much is that? Half m v square, where I assume at infinity velocity is v. As we know, energy is conserved, we can say total energy is constant. Total energy at the origin shall be equated to total energy at infinity. You can see this term is common in both of them, so they will cancel. So what is remaining? Total energy. So if I equate this equation with this equation, this term and this term are common. When you equate, both of them cancel on left side and right hand side. So what is remaining if I have done that, right? Let's try that. It implies Q naught by A plus Q naught by A, this and this. The third term is cancelled, is this one, half m v square. So what's the answer is? We can say 2Q naught by A equal to half m v square. That implies v is equal to, take that to that side, 4 Q naught by A, m comes to the denominator, and a square root. That's the velocity with which the particle is going to move. Thank you for watching. Keep coming back for more and more video lessons. Thank you.